Here we have a set of bivariate data that we would like to draw a trend line on. This data consists of two variables. We have the x variable, which is a number of years since 1984, which means that this would be 1984, ranging all the way up to 2003. And we have a second variable measuring the percent of US households with at least one personal computer. We have a scatter plot where each one of those dots represents one of these data pairs. And the hope is that with a trend line, we can give a rough approximation of all of this data. We see that the data is clearly not linear. We could go through slope calculations off of these values, off of the values in the table, and see that the slope does not stay consistent between each pair of points, or we could just look at the picture and see that the data is not linear. It's close to linear, and you'll see in other parts of the lessons we use the term strong correlation for points that stay close to linear. But in this case, our trend line that we want to draw, we're just going to do our best to draw a line that goes through or near as many of the points as possible. So just a rough sketch of a line that gets pretty close to as many of the points as possible. Now, if you wanted to determine the equation of that line, there really are two different tacks you can take. Tack number one, which is the one we're not going to do, is you try to identify points that you drew through. So maybe I have a point right here. It kind of looks like right there I have a point. And then maybe I have another one right about here that I might be able to use. And because I have those 2 points drawn specifically on my line, I could find the equation of the line that goes through those 2 points. That's not ideal. You're doing a lot of approximating in that situation. You are doing a lot of, let me see where my point is, let me subtract my y values, my x values, let me try to figure out a slope. That's not a very accurate tact or process to use. So what we suggest instead is that you use a couple of points that are really close to the line. And when I say really close to the line, I mean the ones that we already have the data for. So it looks like, based on the way that I drew my line, that this point and this point, the second point and the last point, are the ones that are closest to the line. And really, if there were any that it went straight through, you're feel free to use those because you know you have those exactly. But in cases like this, we want to try to be as exact as we can because we know the trend line is already an approximation. We don't want to approximate a point on top of that. So we use the 2 points that we can identify as being really close to the line, and we build our trend line off of those. So the 2 points that I chose here were 515 and 1961.8. I can find the slope between those 2 points by doing 61.8 minus 15 and 19 minus 5. That gives me 46.8 over 14, which approximates to roughly, rounded to the nearest hundredth, 3 and 34 hundredths. That's going to be my slope when I go to write my equation of the trend line. I can use either one of these 2 points. I'm going to use the first one. Numbers are a little bit smaller, no decimals. I'm going to use the first point, and I'm going to use the point slope form. Y minus 15 equals 3.34. Now we understand that's an approximation too because we rounded, but going out to the hundredths is usually enough for the sake of the accuracy that we desire. X minus the x coordinate, which is 5. We distribute on the right-hand side. Y minus 15, 3.34x minus 16.7, and then we add over, and we get 3.34x minus 1.7. Now, I can already tell that I did not do a terrific job, and you can see that. This line is not perfectly straight. This is suggesting that I should have a negative intercept, but my drawing is suggesting that I should have a positive intercept. So maybe the line that really would go through those 2 points would be a little bit steeper than the one that I drew here. That's okay. Again, we're just looking for an approximation, and we use those 2 points because we saw that they were close to the line. The trend line does not need to be exact. There is no exact for drawing a trend line. You were just giving your best approximation. So why bother doing this? Well, we want to make sure that we're using our trend line for its actual purpose, which is We want to be able to make predictions with it. We want to see where this pattern of data is going, or we want to fill in the blanks in between. So we don't have any data for the years between 1984 and 1989. The trend line could help us fill that in. We don't have any data for the years for 2001 in between, or excuse me, for 2002 in between 2001 and 2003. This line could help us do that. But we also could go beyond the end of the line, and that's called an extrapolation, where we go beyond the end of the line and we make a prediction for a time that's past where our data ends. We're using the predictive power of the trend line to look beyond that point. So I'm going to use 2009, or x is equal to 25, as my point that I'm going to make a prediction on. We take our equation, which was written down here, and we understand that 25 years would be somewhere way out here. So I'm going to say 25 years is 3.34 times 25 minus 1.7. And you're welcome to check me on the arithmetic of this, but that should come out to be 81.8% of households. That is a significant increase over the 6 years before it, which is what we would have anticipated. The answer that we got still makes sense. We're less than 100%. We don't want our answer to go over 100%. That being said, you could see where this strategy might start to go wrong. If we extend this out far enough, and I try to extrapolate out far enough to maybe 2025, perhaps I'm going to end up with a percentage that goes over 100. So this model, this idea of designing a trend line, is a little limited for predictions that are too far away. But if you're making predictions that are near your original data set, it's usually fairly reliable.